This video is about our double and half angle identities, and at the top of your worksheet they are listed for you. We're going to begin with the double angle identities, and so the first three problems are similar to some of your homework problems, and the instructions are a little bit hard. They're just a little confusing. So they say replace the question mark with one of the trig functions, one of the 6 trig functions. So what they mean is use these identities to rewrite this side of the equation until the question mark becomes a trig function. So until this side becomes a trig function, basically that's what they're trying to say. So I'm just going to dive into this and we're going to start working with these. So double angle means, double means 2 times something. So the double angle identities are the sine of 2x, the double of x is what this means, and it's equal to 2 times the sine of x cosine x. Tangent of the double angle formula for tangent, the double tangent angle, tangent of 2x is 2 tangent x over 1 minus tangent squared x. The double angle for cosine, they have 3 identities for this, and we choose which one we want to use depending on which one is going to be helpful to getting whatever we want into the form that we want it to go into. So the cosine of 2x is defined to be a cosine squared x minus sine squared x, or we could use it's also equal to 1 minus 2 sine squared x, or it's also equal to 2 cosine squared x minus 1. So these at the top are the identities, and here are the first problems that say with these instructions with the question mark. So part A says we have to basically rewrite this left side of the equation until it and do some algebra until it becomes just one of the 6 basic trig functions. So we have 1 plus cosine times the tangent of x over 2 is what I wrote. Oh, and so also we need our half angle identities, and I did not write those up here. So if you look at the half angle identities, which are on your sheet right there, we have a choice for the tangent of x over 2, which are half of x, and it's tangent of x over 2 is equal to plus or minus the square root of 1 minus cosine over 1 plus cosine, or it's also equal to sine x over 1 plus cosine, or it's also equal to 1 minus cosine x over sine x. So look at your sheet right here, and so if I need to try to rewrite this, I have choices for which one I want to use for the tangent of x over 2. And when I look at this, what draws my attention is the last one. Tangent of x over 2 is equal to 1 minus cosine x over sine x. That's the one I'm going to replace this with. And the reason that looks interesting and like it might be helpful to me is because 1 minus the cosine of x is the conjugate of 1 plus cosine of x. And when you multiply a number times its conjugate, the middle terms subtract, and it might turn into something else that I can use. So when I look at this, I choose to replace this one with, where did it go? 1 minus cosine x over sine x. 1 minus cosine of x over the sine of x. So this is not a double angle identity. This is a half angle identity for tangent. All right. And so if I want to write 1 plus cosine of x that it's being multiplied by over 1 to make it look like a fraction, I certainly can. And so what I'm going to do now is just multiply these numerators together and the denominators together. So 1 times 1 is 1. Cosine of x times 1 is cosine of x minus cosine of x times 1. The middle term, cosine of x plus negative cosine of x, will add to be 0 because that's what conjugates do. And then cosine of x times negative cosine of x is going to be negative cosine squared of x. So when I multiply this polynomial times this one, I get this. In the denominator, 1 times the sine of x is just the sine of x. Okay. This has not turned into a single trig function yet, so I need to keep thinking and trying to work on this. But I recognize this from earlier. This is one of the Pythagorean trig identities. It comes from this sine squared of x plus the cosine squared of x is 1. I can solve this for the sine squared of x by subtracting cosine squared of x from both sides. And 1 minus cosine squared of x is what I get. And so I'm going to replace this top numerator with the sine squared of x. So this becomes the sine squared of x divided by the sine of x. So this is equal to this, is equal to this, is equal to this. And so this, one of these signs will go into one of these, and this is equal to the sine of x. So the question mark became sine of x when we did some simplification. All right, let's try B. We have 1 plus the cosine of 2x over 2 cosine x. And we want to try to work with this, replace this cosine of 2x with one of these identities, either this one or this one or this one, in order to simplify this. So we have choices for which one we want to use when we're doing the cosine of 2x. That double angle, we have different identities we can use. So if I want to try to simplify this into one trig identity, am I going to use cosine squared x minus sine squared x, or 1 minus 2 sine squared x, or 2 cosine squared x minus 1? I'm going to choose, I think I would like to go with 2 cosine squared x minus 1 to replace this with, because what's drawing me to that one in this case is that this denominator is in cosines and that one's in cosine. So they'll be speaking the same trig language. And I'm going to see if I can get something to simplify using that. So if we do that, we have 1 plus, instead of writing cosine of 2x, I'm going to choose this one, 2 cosine squared of x minus 1. This is what this purple box got replaced with, over 2 cosine of x. And then we look at the numerator, we have a 1 minus 1, and that adds together to become a 0. So this subtracts nicely, and then we just have 2, so this is equal to this, and this is equal to this for B. 2 cosine squared of x over 2 cosine of x. And then 2 can divide into 2, and one of these cosines will divide into one of those cosines. We have 1 times the cosine of x over 1 is just the cosine of x, which is just a trig function. And we've replaced that question mark with that cosine right there. So that's part B. All right, let's go again. For part C, we have the sine of 2x over 2 cosine x. And so we want to try to make this just be one trig function, either sine, cosine, or tangent, or secant, or cosecant, or cotangent. We want to write it in terms of one trig function in terms of x. So we want to replace the double angle here. We're going to replace this guy. So let's go to the sine of 2x, which is here, and we only have one choice, which kind of simplifies our decision making. We can only choose this. So let's replace that with what sine of 2x is defined to be. So it's 2 sine x cosine x over 2 times the cosine of x. And this one turned out to be pretty straightforward. 2 can divide into 2 once, and the cosine can divide into the cosine once. 1 times sine x times 1 is sine of x over 1 is what we get. So this is equal to this, is equal to that. And we were able to replace that question mark with a trig function. So that's how, when you get to that homework, I want to go through a few of those so that you knew how to do them. Okay, now the next one is 2, and it says, given the information, use the given information to find the exact values of the sine of 2x, the cosine of 2x, and the tangent of 2x. And so what they give us, and then it says, what quadrant does the angle 2x lie in? So what they give us is information describing the angle x. And so they want us to find 2x. So we're going to use double angle formulas to figure out information about what the sine and cosine and tangent of 2x are. So this is how you go about this. When they give you information about x and they want you to find double angle information, we will use these formulas. But I want you to look at these formulas before we even approach this problem. If I know what the sine and cosine of x are, then I can figure out what the sine of 2x is. If I know what the sine and cosine of x are, I can also use one of these, any one of these, to figure out what the cosine of 2x is. If I know what the sine and cosine of x are, I can use that to figure out what the tangent is, and I can figure out what the tangent of 2x is. And so, basically what I'm trying to say is, if we know what the sine and cosine of an angle x are, we can figure out anything we need to know about the 6 trig functions for x or the 6 trig functions of the double angle, just with that information. So we're in good shape because we've done this some. We've worked with x before. So here we go. The first one that they give us says use the given information to find sine of 2x, cosine of 2x, and tangent of 2x. What quadrant does 2x lie in? And then for part A, they give us this. To part A, they say the cosine of x is equal to negative 8 over 17. And it tells us that x is in between pi over 2 and pi. All right. This is how we need to approach this. They give us information about x, and they tell us what quadrant angle x is in. Figuring out what quadrant it lies in, this will tell us, is critical. So draw yourself an xy axis. Figure out where pi over 2 is. Figure out where pi is. It hasn't moved from where it always is. And if our angle x lies between pi over 2 and pi, draw a reference triangle right there. And then label your angle x. The reference triangle is the acute angle that we'll make against the horizontal axis. So we're in quadrant 2 right here for angle x. And then let's label our triangle according to this. The cosine of x is adjacent right here over hypotenuse. And remember, the hypotenuse is never negative. So if it's got a negative, it's either going to be on this leg of the triangle or this one. And since it's in quadrant 2, x is negative. That makes a lot of sense. We can use the Pythagorean theorem once we have this right triangle to figure out what this value is. I'll call this b now, and we get b squared plus negative 8 squared is 17 squared. And we'll solve this equation for b. B squared is equal to, what is it equal to? Let me just see what I did before, because I don't know this off the top of my head. I got that this is 15. So I think this is going to be 225. So b is going to equal to 15. So we say b is 15. The square root of 225 is 15. Should this be positive or negative? 15 should be positive because we're in quadrant 2. All right, so this tells us everything we need to know about x. So I'm going to erase this. I was just solving for v right here. Now, what is going to be important for me to know? Well, I know the cosine, and what is the sine of x? The sine of x is equal to opposite over hypotenuse, so it's 15 over 17. And let's go ahead and figure out what the tangent of x is. The tangent is opposite over adjacent, so it's negative 15 over 18. That is x, right? What was my job for number 2? Find 2x. Find the sine, cosine, and tangent of 2x. So I'm going to use this information to figure that out. 2x goes like this. Let's start with, let's find the sine of 2x. The sine of 2x is equal to the number 2 times the sine of x times the cosine of x. All right, so this is 2. What was the sine of x? 15 over 17. What was the cosine of x? Negative 8 over 17. So we multiply 2. You can think of this as 2 over 1. Multiply the numerator together. 2 times 15 times negative 8. And we get negative 240 over 1 times 17 over 289. And so this is what the sine of 2x is equal to. All right, and we note that it's negative. Okay, what is the cosine of 2x? Well, we have choices. You can use any one of these. It doesn't matter which. I'm just going to use the top one. Is this cosine squared x minus sine squared x. So the cosine squared x is negative 8 over 17 squared. And the sine squared x will be 15 over 17 squared. So this is going to be 64 over 289 minus 225 over 289. And this is going to be a negative, I think it's 141. It's 161, negative 161 over 289. So that's what the cosine of 2x is equal to. All right. Now, I'm going to show you one way. There's two different ways to find the tangent of 2x. This, to me, is the easiest way. We could totally put it in that formula right there. We know what the tangent is. So I'll do it that way this time. The tangent of 2x is equal to 2 times the tangent of x. What's the tangent of x? Negative 15 over 18 over 1 minus the tangent squared of x minus negative 15 over 18 squared. All right. This is equal to 2 times negative 15 over 18. That's really going to be negative 30 over 18 divided by 1 minus 225 over, what is that going to be? 18 squared is, did I write that down? I don't want to make stuff up. I'm going to write it down incorrectly, I mean. Oh, that's not an 18. Let me just fix this. This is supposed to be an 8. I'm so glad I looked at that. Where did the 18 come from? Everybody's like, where did the 18 come from? That was just a big mistake. It's supposed to be over 8. I'm sorry about that, but it's supposed to be over 8. Over 8. 1 minus negative 15 over 8 is 1 minus 225 over 64. That's better. So then we have this complex fraction we have to deal with. And so what do we do here is we simplify it. Here's a way you can simplify a complex fraction. This is not 18, sorry, that's an 8. Is to multiply by the lowest common denominator. And so let me make sure I didn't make any others. It's okay. The lowest common denominator of all the denominators I see would be something that 8 and 64 could go into. And 64 is the lowest common denominator. And what you do is you can multiply it in the numerator and the denominator, and it will distribute to both of these. So negative 30 over 8 times 64 is negative 30. 8 will go into 64 8 times. Negative 30 times 8, so that's negative 240 over 1. I can put it over 1 if we want to see that. Okay. Over 64 times 1 is 64. Minus 64 times 225 over 64 is 225. So this is negative 240 divided by 64 minus 225, which is negative 1. I want to make sure I write this down right. Negative 161. So this is 240 over 161 is what we get there. That's the tangent. Now, the question also was, where does the angle 2x? This is x. Where does 2x lie? Well, the sine is here, and it's negative. And the cosine is here, and it is negative. And so where is the sine negative and the cosine negative? That's in quadrant 3. In quadrant 3, also the tangent is positive, and we got a positive tangent. So x was here, and it turns out that 2x, so this is x, right? But 2x is going to be somewhere in here, just for a visual. So we say that 2x is in quadrant 3, like that. All right, let's do part B in just a second. I'm going to show you an alternate way to find tangent. Instead of using this formula, we're just going to use the fact that tangent is equal to sine over cosine. So I'm going to do that in a separate video just for a break.